In aviation, pushback is an airport procedure during which an aircraft is pushed backwards away from an airport gate by external power. Pushbacks are carried out by special, low-profile vehicles called pushback tractors or tugs. Although many aircraft are capable of moving themselves backwards on the ground using reverse thrust, the resulting jet blast or prop wash may cause damage to a terminal building or equipment. Engines close to the ground may also blow sand and debris forward and then suck it into the engine, causing damage to the engine. A pushback is therefore the preferred method to move the aircraft away from the gate. Procedure. Pushbacks at busy aerodromes are usually subject to ground control clearance to facilitate ground movement on taxiways. Once clearance is obtained, the pilot will communicate with the pushback tractor driver to start the pushback. To communicate, a headset may be connected near the nose gear. Since the pilots cannot see what is behind the aircraft, steering is done by the pushback tractor driver and not by the pilots. Depending on the aircraft type and airline procedure, a bypass pin may be temporarily installed into the nose gear to disconnect it from the aircraft's normal steering mechanism. Once the pushback is completed, the tow bar is disconnected, and the bypass pin is removed. The ground handler will show the bypass pin to the pilots to make it absolutely clear that it has been removed. The pushback is then complete, and the aircraft can start taxiing forward under its own power. Equipment equals moving light aircraft equals. Very small airplanes may be moved by human power alone. The airplane may be pushed or pulled by landing gear, wing struts, or even the propeller blades, since they're known to be strong enough to drag the airplane through the air. To allow for turns, a person may either pick up or push down on the tail to raise either the nose wheel or tail wheel off the ground, then rotate the airplane by hand. A less cumbersome method involves attaching a short tow bar to either the nose wheel or tail wheel, which provides a solid handhold and leverage to steer with, as well as eliminates the danger of handling the propeller. These tow bars are usually a lightweight aluminum alloy construction which allows them to be carried on board the airplane. Other small tow bars have a powered wheel to help move the airplane, with power sources as diverse as lawnmower engines or battery-operated electric drills. However, powered tow bars are usually too large and heavy to be practically carried on small airplanes. Tractors and tow bars equals. Large aircraft cannot be moved by hand and must have a tractor or tug. Pushback tractors use a low-profile design to fit under the aircraft nose. For sufficient traction, the tractor must be heavy, and most models can have extra ballast added. A typical tractor for large aircraft weighs up to 54 tons and has a drawbar pull of 334 kilonewtons. Often, the driver's cabin can be raised for increased visibility when reversing, and lowered to fit under aircraft. There are two types of pushback tractors, conventional and tug barless. Conventional tugs use a tow bar to connect the tug to the nose landing gear of the aircraft. The tow bar is fixed laterally at the nose landing gear, but allowed to move slightly vertically for height adjustment. At the end that attaches to the tug, the tow bar may pivot freely laterally and vertically. In this manner the tow bar acts as a large lever to rotate the nose landing gear. Each aircraft type has a unique tow fitting, so the tow bar also acts as an adapter between the standard-sized tow pin on the tug and the type-specific fitting on the aircraft's landing gear. The tow bar must be long enough to place the tug far away enough to avoid hitting the aircraft, as well as to provide sufficient leverage to facilitate turns. On heavy tow bars for large aircraft, the tow bar rides on its own wheels. The wheels are attached to a hydraulic jacking mechanism which can lift the tow bar to the correct height to mate to both the airplane and the tug, and once this is accomplished the same mechanism is used in reverse to raise the tow bar wheels from the ground during the pushback process. The tow bar can be connected at the front or the rear of the tractor, depending on whether the aircraft will be pushed or pulled. The tow bar has a shear pin. The shear pin prevents the aircraft from being mishandled by the tugger. When overstressed the shear pin will snap, disconnecting the bar from the nose gear to prevent damage to the aircraft and tug. Tow barless tractors do not use a tow bar. They scoop up the nose wheel and lift it off the ground, allowing the tug to maneuver the aircraft. This allows better control of the aircraft and higher speeds without anyone in the cockpit. The main advantage of a tow-barless tug is simplicity. By eliminating the tow bar, operators are alleviated from maintaining many tow bars. Also, the physical action and coordination required by the tug operator to move an aircraft with a TBL tug is simpler and easier to learn than with a tow bar. By connecting the tug directly to the aircraft's landing gear, instead of through a tow bar, tug operators have better control and responsiveness when maneuvering. This is most advantageous in general aviation settings, where operators are often required to move more aircraft into smaller, more confined spaces than their airline counterparts. Manufacturers of electric TBL tugs offer a line of models capable of moving any aircraft from the smallest single-engine to narrow-body airliners, military cargo and airline-sized business jets. Just as specialized tow bars are required for a wide range of aircraft, many TBL tugs use adapters which enable the movement of many unique aircraft. The majority of aircraft do not require adapters, and can be moved without any special adjustments to the tug. This is in contrast to conventional tugs, which often use so-called universal tow bars that need to be adjusted for many aircraft types. Electric TBL tugs are gaining popularity among general aviation operators and FBOs as an alternative to gas/diesel-powered, conventional tugs. Being electric as opposed to internal combustion-powered, electric tugs are low-emission, a major advantage for environmentally conscious operators. Also, this enables the tug to be safely operated inside a closed hangar. Robotic tractor. The Lahav division of Israel Aerospace Industries has developed a semi-robotic tow-barless tractor it calls Taxibot that can tow an aircraft from the terminal gate to the takeoff point and return it to the gate after landing. The Taxibot eliminates the use of airplane engines during taxi-in and until immediately prior to takeoff during taxi-out, potentially saving airlines billions of dollars in fuel that is used. The Taxibot is controlled by the pilot from the cockpit using the regular pilot controls. Other equipment applications. While the vehicle is referred to as a pushback tug, it is also used to tow aircraft in areas where taxiing the aircraft is not practical or unsafe, such as moving aircraft in and out of maintenance hangars, or moving aircraft that are not under their own power. Some airlines, notably Virgin Atlantic, advocated towing aircraft to the holding point of the runway to save fuel and reduce environmental impact. However, the practice was discontinued after landing gear maintenance costs increased due to the stresses originating during the towing process. Some fuel must still be burned to operate the auxiliary power unit to provide electrical and pneumatic power to run lighting, environmental and communication systems, unless the tug itself provides these sources of power, which some do. This method also places a larger workload on ground crews and equipment, especially if the aircraft and tow tractor ends up having to wait in a long line of aircraft. Incidents or accidents involving a pushback include Garuda Indonesia Boeing 737-500, operating as Flight 238, collided with a Saudi Arabian Airlines Boeing 747-300. No casualties or injuries. In the media, in an advertising campaign, also documented on the television show Fifth Gear, a Volkswagen Touareg was used to pull a Boeing 747. As cited before, the tractor needs to be heavy to aid traction. The Touareg carried 4.3 tons worth of cement bags, and the tires were inflated to twice the normal pressure to handle the extra weight. Tractor tires have high sidewall ratios for this reason. This is the world record for the heaviest load towed by a production car. Gallery. See also, aircraft ground handling, ground support equipment, visual guidance docking systems. References. Operations Manual Booker Aircraft Tractor KP20 FL Lap 13, Schweizerisch Militärcurrency Museum Full.